Alright kids, this is a follow-up on the last video that's going to show you how to deal with transformations of logarithmic graphs. And so first thing I'm going to do is write out the transformation form. So this is like anything basically that can be done to the graph. So sometimes there's a dilation. You would see the log written. There's going to be, of course, a little base here. You might see I'm actually in this video, I'm going to avoid horizontal translations because we don't see them too terribly often, and when we do a horizontal dilation, we're going to actually learn in class how to turn it into a vertical one, so I'm not going to worry about it in this video. Okay, so what can happen? Well, just like every other function, an a in the front could be a vertical stretch or shrink, and also if a is negative, if this ends up being negative, that would be a vertical reflection. So just put a little note to yourself, you know, if negative, it's going to flip across the x-axis. It's called a vertical reflection, but what that does is flip it across the x. The b right here, the log base b, this is just your parent function. You'll see how to handle that in a second. The h would be a horizontal translation, which means this is going to be your left and right. Remember that left is if you see a positive number, right would be if it's a negative, and the k at the back is going to be your vertical translation, so positive will go up and negative will go down. So these are all kind of old notes. This goes with every parent function you've done this year. And so what I want to do is just show you how to deal with it on a log function. And for me, this is going to be the quickest way. This video is not intended to teach you from scratch. This is just to show you like a quick reference, assuming you've already learned a little bit in class. So our example is going to be y is equal to, let me do like 3 log base 2 of x minus 5. Alright, something like this. Okay, so the first thing you're going to always want to do is just sketch the parent. And in this graph, the parent function is log to whatever base you see. So this is log base 2 of x. That is the parent. And in the last video, I showed you how to quickly sketch that. So let me do that right now. I'm going to sketch my vertical asymptote. I'm going to go through the point 1, 0. And since this is a 2, I'm going to go over 2, up 1. Alright, so this is, these are my 2 points and my asymptote that I'm going to use. From here, I'm going to do my transformations. So you always want to go reflections, dilations first, translations last. So I'm going to go left to right, in other words. So I see this 3 in the front, and what that tells me is that my graph is going to be vertically stretched by a factor of 3. And all that means, guys, is that the y's are going to be tripled. That's what it means. The y's are tripled. So I'm going to look at my y values and triple them. So in other words, this y value is currently 0. 0 times 3 remains 0. So this point will stay here. This y value, however, is a 1. And so 1 times 3 will be 3. So it's vertically stretched 3 times, which makes it 3 times steeper than it was before. So maybe something like that. So I've got those 2 points going on. And then the last thing is going to be inside. Okay, I've got a -5 on the inside, which up here means it's my left or right. And in this case, it's going to be right 5 because of the minus. So I'm going to move these 2 points and the asymptote right 5. Very important that that asymptote also moves. So let me pick this up and move it to 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm at 5 and I'm doing my asymptote. Now this point moves right 5, so it'll be here. And I was a genius, wasn't I? Because now I'm out of room. Okay, this one, I need to move right 5. Okay, so it means I'm over here. I just ran out of room, but if I continued my grid, this green point, right, 5 would be here. And then I can play connect the dots right here. And that is your finished product right there, that light gray graph. Okay, so let me do one more that maybe has a reflection and even maybe like a funky base or something. Give me just a second. Okay. All right, so let's see. If I want one to start out looking a little different, my base would need to be a fraction, you know. So, like, let me do. I think it's frozen on me. Isn't that awesome? Come on, come on. Hold on a second. Okay, so here's the next one. All right, so like I said in the last one, step 1 is to graph the parent. So in this case, it's log base 1/3 of x. So I'm going to start with my asymptote here and my intercept at 1, 0. And then now let's figure out this 1/3 part. I need to go 3 to the right and then down 1. Why am I going down 1? Because it's in logarithmic decay, so it's going to start like this. So here's my parent. Now I'm going to take these 2 points and do all this other stuff to it. So the first thing I'm going to do is the -2. So this has it's actually doing 2 things at once. It's going to be a reflection across the x, okay, vertical reflection across the x-axis. It's also going to dilate by 2. Or dilate is another word for vertical stretch. Okay, so I'm just going to do that at the same time though. I just have to understand that the graph's flipping upside down. But I'm going to take this 0 and multiply it by this -2. So 0 times -2 is still 0. I'm going to take this y value. Now this y value is currently -1. -1 times -2 is +2. And if you wanted to pick another point on here and do the same thing, you could if it made you feel better. But if you understand that we're reflecting this image across the axis and then stretching it, you'll hopefully feel confident sketching that transformation. It flipped, dilated, there it is. So now that's been taken care of. Now the only thing left is this +1 at the back. Now notice there's no parentheses here. If there was parentheses, it would be a left one. But since it's outside of the function, it's going to be up 1 instead. So I'm going to take these 2 green points and move them up 1. Now, where is my asymptote going to be on my final answer? Well, it's going to be in the same dang place. Now, why is it in the same place? Because there was not anywhere in here that I needed to do left or right. The only thing that's going to move this is a left or right translation. We didn't have that. So, the asymptote's still there. Whee! And now I'm just making it go up 1. All right, so that's pretty much it. The only other thing, I might ask you for domain or range or where is the asymptote, and if I were to ask you for that, then the domain is, well, this graph, it starts at the asymptote 0 and goes to infinity. I'm not using a bracket, right, because I can't land on the asymptote. So it's a parenthesis for an interval notation. My range, this is going all the way down and all the way up. And then my asymptote is a vertical line. So the equation of a vertical line is x equals, and where is that vertical line located? Well, it's at 0. So that would be sort of if I asked you for those things. Okay, but that's the quickest way I can think to graph logs. You'll get very quick as you go, but in your mind, even if you're not drawing these, like if you're not literally drawing these in your mind, I hope you are. I hope you know it looked like this, and then we flipped it, and then we moved it up. And of course, the more practice you get, you'll be able to skip a few of those steps. But this is way easier in my mind than doing a bunch of charts. I see a lot of you doing charts all the time, which is great if you know what you're doing. But a lot of you don't know what you're doing with a chart. So this is the easiest way to get an accurate graph. All right, thank you.